Hi everyone. Today we're going to be doing our notes for 8.3, which is going to be stoichiometry and specifically conversions using moles as well as grams. So the big thing here that we're going to be seeing different that we saw previously is that now we're going to be expressing answers both in moles and in grams. So we're going to see both of those being used here, and that's going to involve molar mass. So we'll be seeing that coming up here in a bit. So we remember from our previous set of notes that in a balanced chemical equation, the coefficients, those big numbers out in front, are representative of the mole ratio in that reaction. So let's say we're looking at this particular reaction here. We have iron hydroxide breaking down into iron oxide and water. So to balance it, I'm going to put a 2 here and a 3 here. We always need to balance the equations because that's going to be how we get the mole ratio. So I'm going to put a little note here, needed for mole ratio. So this type of reaction is a decomposition problem. It's always my hint that it's a decomp problem if I'm looking and I only have one reactant. So in this case, I only have one reactant. So in this problem, I'm being asked to calculate the number of moles of water that are produced, so that's my unknown, if I'm starting with 3 moles of iron hydroxide. So the way that I'm going to set this up is I'm going to start with my 3 moles of FeOH3, and I know from my balanced chemical equation up here, okay, for every 2 moles of iron hydroxide, I produce 3 moles of water. So I'm going to be using those numbers in my mole ratio. For every 2 moles of FeOH3, I get 3 moles of water. What this is equal to is 4.5 moles of water. So this is great, awesome, perfect. This is what we learned before. But what if moles, like I did here, I want to actually be able to calculate that into grams. In the previous problem, 4.5 moles of water. I want to know the mass of water that's produced, right? So I don't want to just stop. So what do? We're going to have the exact same setup as we had before, where we have the 3 moles of the iron hydroxide. We convert the 3 moles of iron hydroxide using mole ratio. So this is no different than what we did on the previous slide. Moles of iron hydroxide cross out. And now, because I'm interested in the mass of water, I'm going to go from moles of water to grams of water. So this is where we see molar mass. Molar mass allows us to go from moles to grams and grams to moles. So I know that water weighs 18 grams in 1 mole. So that is equivalent to 81.0 grams of water. This is usable for me in the lab. I can measure stuff out on a scale. So now let's try another one. So same balanced equation. In this case, we're going to calculate the mass of iron oxide if we're starting with 1.30 moles of iron hydroxide. So here, 1.30 moles of FeOH3. Going to do the mole ratio step first. So this allows me to convert into the iron oxide. And then because I'm being asked for mass, my last step is going to be converting moles of iron oxide into grams of iron oxide. So I add up the 2 irons, the 3 oxygens, that's going to equal 159.69 grams. 103 grams of iron oxide is what I produce. So again, to recap, I'm getting this step. This is the mole ratio coming from the coefficients that are out in front here. And this step is molar mass getting me from grams to moles and vice versa. So we can go back and forth here. So the mole ratio step, I'm going to put a little star here. This is in every single stoichiometry problem, always and forever. It will never not be there. So let's try one more, just because practice makes permanent. Here, we are starting with 0.55 moles of water. We're being asked to calculate the mass of iron hydroxide that would be needed to make that much. So we're starting with 0.55 moles of water. We're going to convert moles of water into moles of FeOH3. So I'm going to look at my coefficients up top here. So we have 3 on the bottom, 2 up top. Moles of water crosses out. And now, because I'm being asked for mass, I'm going to go from moles to grams of iron hydroxide. Sorry, it kind of got cut off there. So if I add up the iron, the 3 oxygens, the 3 hydrogens, that's going to add up to 106.87, equivalent to 39 grams. So again, the mole ratio step coming from those coefficients, always going to do the mole ratio. This step here was for us to go from moles to grams, okay? So mole ratio is always going to be in place. The other steps are just contingent. So let's look at this next problem. We're going to do some other examples. For the sake of simplicity and making things go faster, I'm just going to balance this for you, because if we went through and did it, it would just take too much time. So I'm just going to give you those coefficients. And then I'm going to go through and also highlight them so we have them ready to use. So this is how you'd balance it. And the type of reaction this is a combustion problem. I know it's a combustion because I have a hydrocarbon reacting with oxygen to produce carbon dioxide and water. That's consistent with every combustion reaction. So here, very similar to our previous problems, we're being asked to calculate grams of CO2 if we have 2.5 moles of ethane to start, ethane being the C2H6. So we're going to be starting with 2.50 moles of ethane. And our first step is going from moles of ethane into moles of CO2, okay? That's my mole ratio step. It's always going to be there. So I look at my equation. I see that it's 4 on the top, 2 on the bottom. So moles of C2H6 crosses out. I need to get into grams of CO2. So I'm going to convert moles of CO2 into grams of CO2. 1 mole is equivalent to 44 grams. This then is equal, once these all cross out and we multiply everything, 220 grams of CO2. And that's my answer there, okay? We went from moles of CO2 to grams of CO2 at the end because I was being asked for grams. But notice what unit we started with, moles. So this next step is just a little bit different, okay? Remember, we're always going to do mole ratio. That's always going to be there. And in the case of the previous, here, we're starting with grams of ethane. So what happens now? What that means is I have to go from grams of ethane into moles of ethane, then into moles of oxygen, then into grams of oxygen. So now I'm going to have 1, 2, 3 steps that I'm doing. The mole ratio being here in the middle. That's my mole ratio step. These 2 steps are just molar mass steps, okay? So the mole ratio is always there. Molar mass is only needed if we're given or asked for grams. So we're going to start with 1.50 grams of ethane, C2H6. We're going to convert grams of ethane into moles of ethane. So that's my first molar mass step, okay? 1 mole of ethane equals 30 grams. So if I add up the 2 carbons, the 6 hydrogens, they equal 30. My next step then is going to be to convert moles of ethane into moles of oxygen gas. So if I look at my balanced equation up here at the top, those coefficients, for every 7 moles of O2, I need 2 moles of ethane. So moles of ethane crosses out, moles of oxygen is left behind, and then finally 1 mole of O2, 32 grams, okay? And I know O2 is 32 because I just took the 2 oxygens and added them together. So to recap, my first step was a molar mass step. My next step was the mole ratio. I'm going to put a star here because we always have a mole ratio. And this last step is another molar mass step. Those in blue are just required when we are trying to go from moles to grams or grams to moles. This is equal to 5.60 grams of O2. So this slide does a really good job of recapping the summary steps in every problem. So I'm going to outline this in red. In every single problem, we are converting moles of one thing to moles of another thing. This is always going to be there, okay? The things that we see here, these optional steps, are just if you need an answer other than moles or you are starting with a unit other than moles, okay? So if it helps you to have a step process, this might be easier for you. This slide, I'm going to be starting at step 1, only needed when you start with a unit other than moles. We're starting with grams. So let's do one more practice one together just to make sure we're all on the same page. So this is still the balanced equation we were using before, and this time we're starting with 12 grams of ethane and we're being asked to find grams of CO2. So I'm going to start with my 12.0 grams of ethane. And if I look back, so we're going to convert grams of ethane into moles of ethane. 1 mole is equivalent to 30 grams. I added that up before. So I'm just pulling it from before. Then I'm going to convert moles of ethane into moles of CO2. If I look at my balanced equation, there's 4 CO2s for every 2 ethanes. And then finally, so that crosses out, that crosses out. Now I'm going to convert moles of CO2 into grams of CO2. 1 mole is equal to 44 grams. This is equal to 35.2 grams. Okay, so hopefully by this point, you can now complete those calculations, being able to start with any amount of reactant and figure out how much product you make or vice versa, and be able to express your answers not just in moles, but also in mass.